Hey everybody, so this is Dark Guardsman. I'm here to do something a little bit different than what I usually do. So usually when I make these videos, we're talking about Minecraft coding, whatever. I've been doing 3D printing for quite a while, and I kind of want to start doing a little bit more of this on the channel and kind of steer away from just being exclusively about software and more of just hobby stuff in general, like anything and everything I plan to do, am doing, whatever I just want to show off, which I guess has kind of been partially the channel because I've put tons of game content on here, including MechWarrior and everything else, just because I felt like it. So today, because I feel like it, we're going to show off, or at least not really show off because it's not really more of a demonstration, but kind of like a working session of me working on the version 4 of my Airsoft buckshot round. Better call these sabots because we're not really making the buckshots themselves. They're like the little balls you would see in a shell if it was a real firearm. We're actually making cardboard discarding things that will be put into an Airsoft launcher tube for use in playing the game Airsoft. For those who've never played Airsoft, it's basically a version of role-playing that you do in real life, where you run around and you pretend to basically be soldiers, mercenaries, whatever. It doesn't matter what you're doing, we basically play it as if it's Call of Duty, more or less. You show up on a field randomly, you just pick teams, your teams are divided. Not really at random, they try to keep, groups together, but we play that and we shoot little plastic balls at each other. When the ball hits you, you do an honor system and call yourself out, walk back to the respawn, and then go back and play again. I can actually see if I can grab some pictures of Airsoft really quick to show just kind of what goes on in this. Hopefully I don't get horribly, I would say demonetized, because, I don't really monetize my channel, so this doesn't really matter to me. But I guess showing a whole bunch of guns on screen probably doesn't really help with that. So usually with Airsoft you have something like this, which is just some random arena, but yeah, you get a whole bunch of random people. They dress up in more or less actual realistic military gear. A lot of it's kind of, lower quality than what you would expect an actual soldier to wear or anything. And we're basically playing with a mix of plastic metal-like guns, and we're shooting little projectiles at each other. And yes, they do actually hurt occasionally. This is why wearing protective gear is 100% useful. I wear a big ABS helmet with a face mesh for the entire purpose of not having welts like that on my head. But they do make a whole bunch of replicas look realistic. You also get a ton of just, pink stuff. If you've seen it in Call of Duty, somebody has probably made it at one point or not. But what we're actually going to be working on is projectiles are going to be fired out of these right here. So I've purchased 2 of these. I purchased one originally just to prototype and work with it, and then I was contemplating building attachments for them, because what they don't show you in the picture, unfortunately, is that this bottom cap right here screws off. And these are no longer blue. It's kind of really tragic. Their advertising does not match how these are actually made. And they also give you the impression like these are made in somebody's workshop. No, they're produced at a factory in China. You also don't get this, which is really, really sad. This is actually made by some guy on Facebook, and he makes these. They're 3D printed with PVC tubes. They're really, really awesome, but it's almost nearly impossible to get your hands on them because they're made over there, I think in Europe somewhere. And he makes like 2 or 3 of them at a time and then sells them. So they're hard to get your hands on. Oh yeah, they do actually show. So yeah, these bottoms screw off. And what I was originally planning on doing was making attachments you could screw onto these to fire BBs, fire like different like projectiles and stuff for Airsoft. These ones are marketed almost entirely to firing basically cat toys. I can't really call them Nerf toys because they're too solid and too hard for Nerf. They do show you firing these out of them, but if you try to fire these at them, and they're just going to go everywhere. They're not going to work. They're not very practical. There are so many different other products for the Nerf market that work significantly better. Which, on the note of Nerf itself, you often hear Nerf also called Airsoft. It's useful to keep a distinction between it because Airsoft usually refers to the plastic BBs being shot at you, where Nerf is usually these rubberized foam darts or little foam balls and stuff. Then you also have paintball, which some of you might be more familiar with paintball than you are with the rest of these. But paintball is like basically giant stuff, although paintball does have small little BBs as well that they do actually work with that. So we're going to be doing that, and then what we're also trying to do is replace a product produced by a company called Tagin that's based in Russia. This is for a multitude of reasons. I've been working on this project before the current day political and horrible things are going on over there. So this is before any of that. But even before that, like, this product was getting caught up in ammunition bans and was just a pain in the ass to import. We'll see if I can find a picture of what they have. So these are the products they make. I have a theory, which I haven't dug into too much. They were probably originally producing these as military training ammunition, and then they started selling them for airsoft. And the reason I think that, which is kind of partially been confirmed by what I've been digging into figuring out how these are made, is some people have cut these in half. They look very similar to real grenade launcher munitions. So in real grenade launcher munitions, you have basically a spin fuse and a contact fuse. The contact fuse is more or less just a ball bearing and a spring in the back that once it hits something, it goes, that ball bearing will fly forward and then knock a pin, which will set off the munition. And you have a spin fuse that just prevents that ball bearing from flying forward. So it has to spin so many times. And how it works is, at least in the old versions, the newer versions are more sophisticated. I've not really seen too many of how the internals work on that one, just because I don't really care, because I'm not making real munitions. But like the old style one was more of just inertia. As soon as it span up to enough speed and got enough inertia, because as you spin up, you're going to acceleration is going to turn into actual just velocity, and you get to a velocity point, then pins basically fly out and it'll release whatever's in there and it'll do that. But yeah, they sell these. Some of these explode. Some of these make popping noise. Some of these just are solid. They've got smoke rounds. The one that we are going to be doing is what's called the buckshot round. They do have a video on here, which, can I mute you? Yes. The video does not show very well. This is kind of the sad, tragic thing about trying to find information about this. They do slow-mo, and you can kind of see some of the discarding on here. I have a better video because, like, I've been doing a ridiculous amount of research. Let me drag this over here, because I don't remember what is in that folder. You can kind of see some of the quick access where I've got a ton of stuff. Actually, I could show this off really quick. This is what we're going to inevitably end up making. So this is the version 3.2, I think, that's been molded. And you can kind of see some of the problems I'm running into, which is the reason why I'm working on a version 4. One of the problems is that the bottoms are not molding. The pins are not really coming out. And we're just ending up with overall poor quality of the molding. And it's partially to blame to the geometry of the mold, and partially to blame to the manufacturing process I'm trying to use. So we can at least fix the mold section and keep iterating on that to make it easier for the manufacturing process to be optimized. But let me find the video really quick on my other monitor. I did not prepare anything for this. So I have kind of a lack of stuff ready. I swear I had the video. So there's moments where I go and grab videos. I think it's this guy. Oh, that's actually hit film. That is not what I want. We do not need to load editing software while we're also running recording software, because this is how you crash a computer. I really don't have the video on hand, but I guess I can go grab the exported video. So this is one of my test videos. So I don't have the tagged video, which is unfortunate, but this kind of shows what this actually wound up working with. You can kind of see the discarding bits moving. Some of these are paper you're seeing in here. The actual cardboard projectiles are moving significantly fast, and they end up going almost all the way to that stump over there and then landing on the ground. We actually did recover those. They were fully intact on recovery, and they are now sitting in that center block that's right in that picture, which is actually my forge set up for melting aluminum cans. The forge is not out because I don't leave it out in the rain. But yeah, we left the bricks where they were at, so we just knew where we were doing it at. But yeah, so I threw the cardboard in there, and I've been letting them get rained on to see how they decay, because we're trying to do biodegradable. But yeah, this is what we're trying to replace. These are some kind of rubberized plastic. They're not biodegradable. They're probably going to sit on the field outside for years and years before somebody does anything with them. Most likely get upon the road. The bottom shells as well are not biodegradable, and they aren't exactly reusable. Now, if you recover the top two pieces, you obviously could try to reuse them. You're going to have to cut out probably a new top piece. I have two of these. I purchased some for research. They are not compatible with just about anything. You can't get them to fit into the small tubes I was showing. So these guys, they will not fit in here. That's the reason I bought them originally, is I was hoping they would work. They are entirely built for the launcher they come with. I have been told you can take them out of this plastic and you can shove them into these tubes. But it does cause a ton of problems. Let's see if I can actually find the launcher this comes with and explain why these are something I'm trying to replace. Their cheaper version is $794 if you can find them. I've seen some people reselling them for $1,000 on eBay. They're not cheap. They use a CO2 cartridge that sits up here in the aiming sight. You pull back this lever right here to actually start the CO2 cart, and it's basically a manual trigger. You pull it down, it releases gas, and it fires down. Now, some people have converted these to run on HPA themselves in CO2 canisters that are like actual tanks and stuff. I have CO2 tanks sitting around me that I use for testing. You can also buy a standalone kit that will help convert it to HPA, and I don't remember if this includes all of the parts, or you can buy the pre-assembled version, which comes with a little tank that does not last you very long. I actually have a small tank that's the exact same size. I ran through it in like 15 minutes with an HPA handgun. They do not last, and the handgun uses significantly less air because we've tuned the one I have, which is actually my brother's. I just use it because he never goes out anymore. But yeah, this is the one that's actually marketed to be used with all these different ones. It's like their version 2 or so. And they also have a recommended temperature as well, which I don't remember the conversion to Fahrenheit, but this system would not work in Ohio during our winters. Actually, let's go ahead and convert that. Negative 20 C to F. Yeah, so I have actually played out side in negative 15 down to negative 20 before. I won't do it again because we did an indoor field. We did the Odin's field somewhere north in Ohio. It was negative, I believe, 18 that day. And after about 7 games, I eventually gave up because my body physically was not able to function anymore. It was getting to a point where it's just like I wanted to be in the car and just warm. The place did have heaters and stuff, so when you were out in the lobby, it would at least be like 40 degrees, but when you were on the field was a warehouse and had no heating. But yeah, these things are like hugely expensive, and you have to have this to launch their rounds, or you have to go buy one of their $100 systems. So I was like, you know what? I'm going to go buy these $30 ones, and I'm going to design my ammunition. And it took me, a while to eventually get around to doing it. So here, a couple weeks ago, I actually started modeling everything else. Let me actually go back out to Tinkercad. Now, we're going to use Tinkercad for this just because I really don't want to learn any of the advanced software anymore. I used to know how to use CAD. I used to be really good at it. I used to know how to use Blender. I used to be half decent at it. I used to know how to use a software called Animator, which I could do almost anything in. But then I was like, somebody tipped me off to Tinkercad, and they were using it to design 40K models. And I'm like, if you could design a 40K model in there, I could probably design anything in this. But anyways, I went ahead and designed this. You can see this was designed here last month. And let me go ahead and tinker this and kind of show you where I started off with the design, so you can kind of understand like how we got to where we're going. So the first thing I did was to model out the dimensions of the tube itself. I don't care if this is accurate on the exterior. The only thing I care is I get my dimensions right for the diameter of this, the height, and roughly approximately how this is going to probably function. From that, I basically started to just design a shell. And the way Tinkercad actually does work is you're kind of merging pieces down together and everything else. So if I grab this, unlock it, do Control-C. I'm going to have to remember hotkeys in a second because for work I code on a Macintosh, for personal use on Windows, and then for coding I'm starting to use on Linux, so it's like driving me nuts learning all the hotkeys again. But I'll grab this, and yeah, I've copied that. Let me lock this again. I try to keep my old versions. I try to lock them so I don't accidentally undo them. But you can actually ungroup these, and I can actually show you kind of how this started out. Let me make sure I can ungroup everything. It's all grouped. So this one was pretty straightforward. I ended up doing this kind of cone-like shape thing. I think it was this guy right here, which is called a paraboloid. Weird pronunciation. But I built that, and I believe I can hide this. This button. So I did that. I put a cutout in the here, another cutout there. And I did the same thing for the cylinder down here. It's basically just a cylinder with cutouts on it. And that got me a basic rough approximate shape of what I was aiming for. Now I was trying to be a little bit more aerodynamic, and then I realized this wasn't going to 3D print well, and it was not going to mold well. And more importantly, it wasn't going to do what I actually needed to do, which I needed to discard and break away. So how the tagging ones work, and it's the reason why they're so flat in the front, is when the air hits it as it's going up at high velocity, it is actually going to force the two halves to split apart from the air pressure alone. It's also going to be the BBs are going to help a lot with that and everything else. Speaking of BBs, a really cool thing I can show here is how this is actually going to look inside. Now, this isn't a good approximation of how many BBs are actually going to fit in here, because you can kind of see they're cutting through the walls and everything else, but it gives you for this amazing screenshot that you can share on Twitter and get people hyped up about something that you actually haven't produced and brought to market yet. It also, just looks absolutely cool. But so there's that. Now, if I go back out and we go look at the next version. So version 2 I made immediately after I made version 1. So if we go here, you can see literally made on the same day. And we go tinker this. This is when I started, figuring it out a little bit better. I started going through iterative steps and started doing a little bit more work. So this is the version I ended up coming with, and I was like, okay, that's pretty good. And I'm like, oh, but I need to do the cardboard on the top. So I'm going to use probably a cardboard disc or paper disc on the top. I'm probably going to pick paper for the sole reason I actually want it to fall apart much more quickly than the tag-in version. I want this to waste as little energy as possible on the BBs themselves, because the ideal of what you're trying to do with a Sabot is you want to get the BBs to stay at a high acceleration rate. So when you're trying to hit somebody out like 40, 50, 60 feet, you actually hit them. Which those distances are pretty impressive because BBs tend to lose energy really fast. The field I play at for outdoors is 400 feet per second is the rule for the velocity your BBs can be at when they exit any device you're using. Grenade launchers generally fire far, far lower than that. The shower shells I have, which let me go ahead and do Airsoft shower shells and show what I'm talking about here. You guys can all Google this if you ever want to do any of this stuff, but these are what shower shells are. They have a ton of little holes in them. They look really, really cool. They're actually very ineffective. Although that's kind of neat. I didn't notice they have, I think it's a speed loader. I'm going to have to go look at that later, because I'm always interested in finding newer versions of that stuff. But yeah, so these just shoot out a ton of BBs, and if you ever get into the sport, one, grenade launchers are horribly ineffective and don't really work. You're just going to want to know that ahead of time. You're going to have tons of problems with them. 2, the shower shells are super disappointing, except for this guy. This guy's actually not too bad. I have one of these. You just have to be careful. The front will explode and break off on you after a few shots. Thankfully, it does not hurt people. These versions are actually not too bad. This is the other type. These are also called shower shells, but they actually act more like a blunderbuss than anything else. But anyways, yeah, so I was saying, with the shower shells, they shoot about 200 FPS, sometimes lower, depending on what gas you put in them. If you follow the normal rules that a lot of fields like you to follow, green gas is the preferred one to put into the shells, which means you're going to get like 100 FPS, which means your BBs are going to spread very fast. So if you're shooting at somebody at like 10 feet away, your BBs are going to spread like 15 feet wide, and maybe a dozen or so might hit the person, if you're lucky. I have this problem all the time. And if they do hit them, they don't usually call the hits because they can't tell they were actually hit, because by the time they hit them, the amount of velocity left in the BB is so low that it feels like a flower hit you. And I've been shot by my own grenade launcher before, so I know at certain distances it hurts, and at other distances, like, you don't notice at all. Especially for people who like to wear, big baggy clothing, everything else. And my air ventilation system behind me just turned on. The cool thing about home automation is you can make things turn on automatically. The downside is when you're recording a video at 2 a.m. in the morning, things will just turn on when you don't want them to turn on. But yeah, so we want to waste as little energy as possible. So yeah, we put a cardboard, or I decided I wanted a cardboard cutout here, and I'm thinking paper will be the way I'm going to end up going. And that should help reduce the amount of velocity, because if the BBs decide to accelerate really, really quick and the shell decides to decelerate, the BBs will just bust through the paper. But if there's cardboard there, what will inevitably end up happening is that they'll hit that and they'll lose velocity because they'll be accelerating the shell again. So we don't want that to happen. What we actually want to really happen is we want the Sabot to discard almost without touching the BBs themselves, which is impractical, but you can reduce the amount of contact and reduce the amount of energy loss as much as possible in that interaction. And then I was getting out to more duration designs of this. So with this design, at least with the version 2, I decided to start putting pins in it, and I decided to work on like how these pins were actually going to behave. I believe these two versions are actually not significantly different from each other. I think the only difference was I fixed some issues with how this top ring was there. I made it thicker, made it work a little bit better, made some like minor changes as things went on. Then once I got this version, I basically built molds. Now the way I built these molds is not the most practical. You basically take this guy, you turn it into a hole, you flip it sideways, and you just kind of put it over top of some blocks, and you do cutouts. And then once you get your cutout, you then merge this one with this one as a copy, and then put it together here. So if I actually degroup this, you'll kind of see as I continue degrouping how it was kind of layered up and built. So you have the hole here in lower half and everything else, and it just basically is a series of, you know, different components being merged together, more or less, which is what I really do like about this software. Now, can I actually undo all my stupidity? Control C. Yes. There we go. I also had pins hole through here. I actually got rid of these here later, and I have alignment pins. Somebody actually recommended to me that I actually do more alignment pins, not less. This guy, if I ungroup him, is basically just this inverted to flip over here, with some small modifications as well to kind of fix various issues, but it does more or less the same exact thing. And we'll do Control V again and put it back together here. And then here's me putting both parts more or less together to kind of understand how they're going to mesh up and make sure they align and make sure there wasn't any problems. At least I think that's what that is, because I don't see what's going on in that part. But anyways, we'll move over to kind of what the version 3 is. So this is not the original version 3, but this is practically version 3. So I went ahead and copied this, was getting ready to start, was like, hey, we're going to make a video to kind of go ahead and start talking about this whole process. It's now taken us like 20 minutes to get to this point, which if I knew how to do chapters really well on YouTube and, you know, break content up and pre-plan it, this would have been perfect. I could do a nice big skip to the actual start point. But we're here, and we've got the version 3.2 round. It's gone through some small iterations. There were smaller pins at the top. I decided to go for the same size pins on the top and bottom. The alignment's a bit weird. The pins are a pain, and they rarely ever work. So if I go and I go find my notes folder, because I actually keep notes, which I've found to be really useful if you ever get into any type of anything. Keep notes. It saves you a lot of mental stress of having to remember everything, and, you know, you can go back and go, hey, I already tried this, or I tried this and it didn't work, or here's some new theories I can actually go through. So I go find my image folder, and we can actually drag this over, and there's a lot of useful stuff in here. Like, you can actually see this is the first version that was actually built and test fired. It barely fits. You can see it's kind of made of composed newspaper. Deconstructions of various bits of material. Composition of doing cardboard particles rather than doing pulp. We eventually went to pulp because the particles, they work, but they fall apart. The actual molds being produced, we actually have 2 of these, and we've been constantly using the produce versions now. I've got like a stack of enough to make 2 on my desk, 2 more being molded in the other room, and we've kind of destroyed like a dozen of these now. The actual shredder we're using, I love this thing. I got this from Goodwill for $30. I was going to use it for shredding soda cans, and then I was like, you know what, I'm going to use it for its original purpose and shred cardboard. That's the bottom of it, by the way. The top is completely safe, although I'm going to probably fix that and make it unsafe. But yeah, the molding process, and let me see if I can find any of the pictures showing how these actually look when they're molded. So if you look on this here, you can kind of tell, one, I have problems with flashing. So this whole side right here, that's flashing. We end up cutting that off. It's no big deal. And with this one, I was intentionally introducing flashing to try to see if having the flashing and then trimming it would result in a better fit, which it kind of does and doesn't at the same time. But where the pin holes should be, and if I actually kind of mark them out here, this is where there should be a hole and there's not. This is where there should be a pin and there's not. These are not coming out because, one, they're too small. Now the bigger pins, if you notice, they are working. So these are the pins I use for alignment over here that the flashing is getting caught into, and they're showing up incredibly well. And this is just, I believe this was a ad from a local grocery chain called Kroger's. I think it was Kroger's, might have been John Eagle. I shredded it because I'm like, I don't care about your ad. I don't do coupon clipping. There wasn't any coupons in it to start with, so I don't really care there anyways. And I mostly shop from Walmart via the online app, and the only reason I use Walmart is because Amazon won't deliver it to me anymore for food because I'm too far away from the distribution center. But yeah, also with this one, you can kind of see hilariously in the back, a piece of the mold broke off. That's the other thing we got to fix. But yeah, so the pens don't work in this, and I don't save because I don't want to damage my notes. So these pens aren't working. This back is one of the things that isn't showing up very well. This is actually kind of too thick on this one, although I'm going to probably keep that thickness on it. And I think this top isn't actually even really necessary in the design to have it work properly. So we want to kind of try to figure out what is a mold I can make that is going to function more often and going to result in better quality prints. Because we're going to have to iterate through this. So this is going to be my version 4 design of the part. The molds themselves are probably going to go through several sub-iterations. Once I get a part figured out that I kind of like and is going to consistently work, I'm going to start iterating through different ways to produce the mold. Things that are on my list is to produce a mesh, because I've seen a lot of YouTube videos online of different manufacturers all over the planet, and the majority of them seem to like vacuum molded meshes. So what they'll do is they'll produce a CNC milled mold, and it might have like 2-3 dozen parts on it, depending on the size. If they're doing like little cardboard things to hold like Easter eggs, for example, there might be like 30 of those on a mold. But then if they're doing, say, like takeoff food containers, there might only be like 4 of them. If they're doing egg cartons, there might only be 1 per mold. And they might be doing multiple of these molds, by the way, too. So egg cartons, if you ever go watch how it's made, they have like a video that's like 4 or 5 of them on them, but they got the CNC mold, and then they'll put a mesh over top of it, kind of like chicken wire. Actually do that, and I can actually show what these look like. So paper pulp molds. So yeah, these are different things you can produce, and these are DIY ones, by the way. Here's a company which I'm going to try to figure out how to reverse engineer their tech, because that is phenomenally amazing. That is plastic, basically, but that is made out of paper. They do paper, cornstarch, and water, basically. But yeah, here's this mold process right here. So you can see kind of the molding of this. This is, again, for that. And if I go pop this open, but quickly mute it before I get, copyright strike. And if we scroll through, you can see the blending process, which I'm using Blender to do this. But yeah, they have this process here. So what ends up happening, they make the vat, and they stick in the vat. A vacuum sucks up the pulp on top of the mold, and then they bring it up here and they just kind of wash it off, which is, I still have no idea how this works. It's going to take me so long of reading to figure this out. But yeah, they just grab it with another side of the mold, take it away, and, dry it out, and they produce egg cartons, which are phenomenally amazing. And if you've ever picked up an egg carton, it's got a weird texture to it, but at the same time, it's weirdly got some strength to it and somewhat of a consistency. Like, it doesn't fall apart, it doesn't break apart in your hand. But you can see how they get the meshes here. This is something I definitely want to give a try to. I have no idea how I'm going to achieve it, but it is definitely on my list of things to give a try on this one. Specifically because draining water off this is actually hard. I'm using clamps right now to press these together. And I made the mistake of putting my drainage holes in the bottom where the clamp engages, so the drainage holes are kind of only useful for acting as injection pinholes, and adding extra flashing, because I'm having to trim flashing off the outside of these because the pulp will get down these holes. And likely not a lot of it's got down the holes, so I haven't had to worry about, the part getting super stuck. The other reason I also want to do wet meshes is getting the parts out of this while they're wet is almost impossible, because they'll fall almost completely apart. But if we get to meshes, I can basically run a whole bunch of air through it and pop the part out without it getting stuck on the outside. I do have a version that's using cornstarch right now. But yeah, let's go ahead and get to work on this. So we want to make another version of this, and rather than, starting over from scratch and trying to get the specs to correct, I need this to be 35 millimeters in order to fit in the tube. That's the only metric I actually care about, is the diameter. So let's go ahead and we're going to delete these guys because I don't care. I am going to run this all the way to the side to just know how we started, lock that in place, and I am going to then degroup this and slowly, deconstruct. Actually, let's go back one layer and get rid of the pens real quick. That was easier than I thought. You just move the model, it works. So we have our center mark in place. So when you're messing with Tinkercad, it's very useful to, just drop the center pin down here. Now, I haven't watched videos of how Tinkercad's used. I've been guessing my whole time. I'm probably going to go through some training courses here later, because I want to learn some better CAD software than this. Tinkercad is absolutely phenomenal for doing basic stuff, but I'm starting to get to the point where it's starting to show its difficulty. If I was 3D printing this would be perfectly fine, which is the whole reason I've been using Tinkercad. Is 3D printing is amazing. But yeah, we want to center this. So let's go ahead and degroup it one more time. Get rid of my big kill box here, and grab all this, and let's get this centered, because that'll help move things along. You've got a center point, you can basically move every part around you. Now I need to get rid of this base plate and figure out what I'm going to do with it. So it's unclick, click there, delete that guy. Now it looks like I've got more than one. Actually, hold on, I deleted the wrong one. When you're doing cutouts, by the way, one of the tricks I have learned is to overextend your cutout, so that way it's easier to select them. I didn't do that with this one, so I had a little bit of trouble selecting. So I kind of am okay with almost giving it a flat bottom. The whole reason I was doing a curved bottom is you want to kind of trick the pressure into pushing the round rather than trying to escape around the round. I still kind of want to do that, but I gotta think a little bit smarter about how I want to do that. I still want these ridges on the bottom here, because this is the whole reason to have these here, is so that the insertion of the round into the tube is easier. If you make it solid and, you know, perfectly geometried, it's going to be a pain, and your user base is going to hate you. More specifically, I'm going to hate myself, because I'm going to be using these probably for a good several months before I even try to sell them to anybody. Even though I actually have customers already. I haven't even finished the product. There's people that's like, oh, I would like to buy these from you. And then my housemate Snow has already been drumming me up customers. Somebody was like going to offer me, I believe, $2 a round. And I'm like, I'm trying to sell these for $1 a round, planning on them manufacturally and, you know, labor costing me like 50% or less. And the dollar would compensate for, you know, packaging and handling and any kind of, well, I would still make people pay for shipping. But yeah, so I gotta figure out exactly what I want to do here. Because we could just keep it as is and just call this version 4, but that kind of feels like cheaping out. Do I need this to be as aggressive? For starters, let's go ahead and hide a few pieces. Yeah, that's just around this. Does not make any real difference there. Oh, that's right. Control Shift D. I forgot one of the things about hiding is that it doesn't actually do what you think it does, and you cannot Control Z in this software. Okay, so there's the inner ring I have. I don't think I need this anymore. Because if we're going to go through stuff, why don't I just delete that earlier? Because I still need to do a paper disc, but I don't have to actually have something to hold it in. Because I could make a really simple mold that would basically paper mache insert into this top half. Because I still have to fill these, which is another problem in itself. Yeah, that's actually going to cause some difficulties. Because we want to make it as easy as possible to fill. Which actually brings me to the idea of the tag-ins. I actually wish I kept one of these tag-ins on my desk, because I'm trying to remember what they actually did for theirs. So we can go back to these guys. Yeah, they have a foam insert at the top here. Now what's interesting about this is how did they fill this and then get the foam insert in that without it being a pain? Because you got to keep in mind manufacturing. If you're producing a product, you want to make it possible to be produced by a machine as easy as possible. Because if a machine does it, you can produce more of that product for cheaper and get more out the door, which means your customer doesn't have to pay as much money. But if they're building these by hand, I also could explain why they're expensive. The other part is really expensive. It's just, you know, that's a lot of plastic. BBs themselves also add to the price. A bag of like 3,000 BBs is like $20. If you buy heavyweights, if you buy like low weights, it's like $8. You can get them in bulk, but you don't want to buy the lowest weights because the 12 or 0.12 gram BBs tend to shatter violently when they hit things because there's a lot of air bubbles in them. You want 0.2 and up, because 0.2, even though they tend to kind of shatter, they at least break evenly in half, and you don't end up with a lot of shrapnel in somebody's face, because I've inhaled and, you know, got a taste shrapnel from BBs before. It's not pleasant, but the higher the weight you get, the lower probability of it cracking and breaking in half. I say this, I've had some .3s break in a sniper rifle I was using, which destroyed that rifle. It was cheap, so, you know, no big loss, but it's also a reason why you buy good quality stuff. Yeah, so they got a foam disc in here. So that they've molded, probably with injection molding, and I still don't know what this material is. This is where I wish I knew a lot more about industrial engineering and stuff, and I'm just now learning stuff. I got books I'm reading and everything. But I know this bottom part is, you know, some kind of just, probably like normal plastic you use, so like PLA. Probably not. It's probably like PETG or something, some kind of thermomolded plastic that can easily eject. But the top is rubberish. It's made to actually be a bit softer and kind of flex a lot more. So it could be possible that they've flexed this apart slightly and inserted the foam into it, because I know it doesn't want to come out on its own. I can't imagine they've filled the BBs in this while it was kind of broken apart halfway and then insert it in there, because it just sounds like a pain. They've got some kind of process to it. Let me actually check my folders. Drag these over here again. I really need to clean up my root folder of Dropbox, because every time I go to open it, it's like there's a ton of pictures in there that preferably shouldn't be on camera. I don't really care, to be honest, because I've shared them in so many public Discords it doesn't matter. But I actually should have a research folder. Airsoft tag-ins. Because I actually do have a research folder. Let's see what I got in here. I say extreme range 30 meters. These actually go farther than that. I just, not very smart. 75 BB, so I actually did count these, apparently. Breaks apart. Pack of 2. So that's what I purchased, was a pack of 2. They're pretty cheap when you buy them in bigger packs. Buy them in small packs, you're basically paying $4.50 each, which is the reason why I want to make my own as well, because Airsoft is so expensive. It's easy to spend $50 a weekend doing this stuff, and I was going every single weekend, so I was burning through my cash really fast. What saved me on that is I would usually trade my skills and services and other things to kind of compensate for that money. So it was I wasn't blowing $50 a weekend, but I was I'd purchase $50 worth of stuff and then turn around and make maybe $30, $40 back. It was not that big a deal. And some of that money was also, food and gas, because, driving is expensive. But yeah, so parts, weights. I actually went through and measured a lot of this. It shows you I've kind of been messing with this for a while. I got some pictures here. The video I was looking for? It's probably that right there. Yep, that's the video I was looking for. This was some Russian guy shooting everything. And I believe I have screenshots of the Sabot separation as well. But what I want to show is these pictures, because I remember I did take them. Yeah, this is what this looks like. And you can see where I've been taking inspiration. So they do pins on the bottom. I didn't realize this. There's only pins on the bottom. There's a foam disc at the top. So the foam disc at the top is holding it together. And yeah, you've got the big divot in the bottom, which they also... So they did as well. I actually forgot all the things they did. They have a bit of a plastic cut on the bottom too. Here's the halves. So they are doing a really big divot. So I could expand the divot at the bottom of mine, and that might let me actually do this a little bit better. Let's give that a try rather than me completely abandoning the concept, because as gas expands, because CO2 will expand as soon as it hits atmosphere, as you're taking it from a liquid state to a compressed state, usually when you're working with it, and then you're going to decompress it into a tube and it's going to accelerate really fast. It's the same idea as a gunpowder weapon. You're basically doing rapid expansion of a gas to act as your pushing agent. It works like a piston, more or less, if you want to think of it in terms of mechanics. But yeah, so they hold the top there. I don't want to do that because it's going to make loading difficult. But I do need to give some consideration on how to keep the BBs from falling out. Otherwise, I'm going to, fail at my objective to build these. Okay, so we could just make the shells taller. Because what did I measure them to be height-wise? Because did I measure... I didn't really measure a lot of these. I did realize the weights on them were really weird. It's very unlikely that they're actually that kind of weight. They could be 0.35s, which would be insane. Because you don't really want to go too high on your BB weights. It actually takes away a lot of your velocity, which takes your range down. I purely measured weight of them, so I didn't take into account what their heights were. So we could make this taller. We do want to drop... I don't want to drop this too far, because it is having problems molding. So let's take a look at my ones on my desk in front of me, which I know you guys can't see, and I don't really care to, fix the camera to make it let you see it. But we could make this 3 millimeters. And I think moving it up by the amount that we just dropped it. Okay, apparently that's not what I want to do. Control Z. So we do 23.5. That'll work. And I hope my girlfriend isn't being picked up in the other room, because she's currently live streaming and she's doing another one of those 20-hour live streams. She's been pretty particularly bad about it. But yeah. So that'll go up there. I need to increase the height of this, which I think I'm just going to raise this. So this will be 15, I think. Yep, it's not cutting into that at all. So just still give me my reasonable hole. I'm going to skip alignment pins altogether for this current version. But then I need to add a cone back to the bottom, so I also need to increase the height of this. So let's go with 5. Make that a little bit more aggressive. I'm going to do 2.5 here. This is also why I want to talk about when you put a center measuring stick in here. You could literally just divide in half your part and it'll move up to be centered with what you're working with. It's really useful. Let's see, so I deleted my cone at the bottom. It doesn't need to be a cone. Because if we go ahead and I reshow everything, one, this is going to need to change size. So we moved, I forgot what we moved the bottom up by. I want to say it's 20 now. Yeah, that's about right. So that's now going to be 15.5. Apparently not. We'll do 15. That was correct. Let's go ahead and merge this all down real quick. And then I want to grab a delete block. And I'm going to oversize this. I've been getting in the habit of oversizing all of my delete blocks because I've been having difficulties with, if you make them perfectly sized, they tend to not want to cut off the parts you're looking for. With this, we can do 0 here, do 40 here. Yeah, that should work. Let's actually make this 18 so it's a little bit covering the bottom. I think... no, it's not centered properly. So the thing's 35, 15, 17.5? No. Well, it would be if this was actually 35. Which will make my math a little easier. So if I merge this down, that gives me my half. Yep, that's what I thought. Really thick base. But while I have this half here, I can take that opportunity to size my divot at the bottom. But I gotta decide what shape I want to use. Now, previously I was using a cone, but I think what I'm going to do is get a cylinder. Now I want a reasonably good amount of material around it, so we know this is 35. I want to do about 5 around the edge. That means this needs to be about 25. I think. Yep, that sounds about right. Doing math in my head is probably the worst. It's what got me in trouble when I was in engineering school all the time, is I would do the math in my head, and the professor's like, oh, you can't do that. And I got it correct enough that the professor just started letting me do it in my head, and then I started making mistakes. I started getting in trouble for it. Luckily, I didn't stick around for engineering school very long, because even though I could do the math and stuff, and I started doing it by paper again, but doing it by paper is boring. Incredibly boring. Okay, I wish I had a way to measure how thick that material is up there. Because that's what's going to get you. Because this is going to be a solid block right here in the mold. But that's going to be the part that's above the blank is going to be what is actually going to be having cardboard pulp be put into it. It's what's going to get me on the design. I always have to think about that as how this is going to be molded and how it's going to release from the mold. So for example, I wanted to put a curve on the bottom here, and I was like, oh, that's going to not want to release from the mold very well. Actually, no, it might release from the mold. Now thinking about it. Because curves like to, I think, release from molds better than squares. So I should have made this more smooth here, just because I know the 3D printer can actually do it. But I think I'm going to intentionally leave it blocky, because there is a novel marketing thing to 3D prints that the layer lines and the line showing, people buy it because it looks cool. But yeah, that'll end up with a pretty thick base. I'll have a pretty good amount here, so the pulp should be able to get down into these curves. Because I noticed it deals fine with 5mm gaps. But this guy above here, I think is going to be an issue. Why is there not workplace? What are you? Oh, you are neat. Even though you probably just threw off like all of my geometry. Yeah, so it threw off my measuring spot. So it's a neat concept. I have to dig into what that does. I think the easiest way I'm going to be able to tell how thick that is just to come over here with a shape. Also make it a hole. And just like change the height. So I'm going to guess it's 3mm. If we do 0 there, we do 0 there, and we do 0 there, and we just lose our part because I wasn't paying attention to the height. Actually, that worked. I don't need to zero it out. So yeah, I was correct. 3mm. So that's going to be in difficulty because that's what those pens were. Those pens were like between 3 and 4mm, and they weren't molding. So I need this to be a lot less aggressive. Let's do 4. It's not a huge difference, but that might mold better. As compared to our previous version, it's going to be easier for stuff to get into. As the previous, actually, let me go find the previous version here. Actually, we'll do open new tab. Back over here. Actually, no, I have the previous version still in the level. Yes, I do. So if you look at this, and let's go ahead and how did I even get this rotated in the first place? That apparently happened. So we just want to compare off this because this is what's going to end up doing us if we don't pay attention to how it turned out. Okay, so when I was molding this, that spot right there would almost never want to fill with paper pulp. So we've definitely got a thicker spot here. So we're doing about 4mm, 4mm on the bottom here. I still have concerns I won't get enough paper pulp into this, but we're going to give it a try. It looks a little bit less sexy in terms of the pens and, you know, that stuff. I do have more material down here to put pens if I decide to go back towards pens. I don't think I want to go back towards pens. I think there's a better strategy. So I think what I'm going to do is I actually might just glue paper to the bottom of this hole here and glue the two parts together with a biodegradable glue. That means when it, you know, it's out in the environment, it's going to break down because I really need to pay attention to all the materials I use. The downside is I am using cardboard that is coming from like Amazon and stuff, so even though the boxes are kind of biodegradable, and well, they're not biodegradable, they're recyclable, and there's a difference to keep in mind with that, is a biodegradable object, if it actually is properly biodegradable, I can throw it in a dirt pile in my backyard, and in a couple months it's going to disintegrate. Recyclable means if you put it under the right conditions, you can reuse it. And sometimes they'll construe the two because you can break down certain recyclable materials back into something, but you usually have to give it some conditions that aren't normal, like high heat, high pressure. You have to shred it, you have to introduce bacteria, yeast, all kinds of other stuff. So that does cause issues. But yeah, we're not going to put alignment on the top here. I'm almost tempted I can roll these over. These top here, so I might end up thinking about that because there's an idea we could produce an actual shotgun style wad style instead of a sabot, but we'll do that in a separate video when I get around to it. For now, we're just going to keep modifying this. But yeah, so we'll do paper down here. The other idea I have is I could do an insert somewhere in here, but if I do an insert, then I'm definitely looking at another problem with, you know, pulp filling around it. unless I want to, you know, cut stuff into it, which I want to make these as easy as possible. I want to get to the point where I'm literally taking a pre-measured cup of pulp, throwing it into the mold, and just shedding it. Or even better, if I get the vacuum molding to work, I can literally just drop the whole mold into a pulp container, pick it up, eject all the parts, and then start again. Because I need to be able to make 100 of these an hour to compensate for how much money I make. Because even though I don't actually make $50 an hour, I usually charge people freelancing that amount. And if I'm going to make any money doing anything, and I have to pick between writing code for somebody and making $50 an hour or making parts, the code probably sounds better if I can't make enough parts an hour, which I always have to consider. So unless I can automate the process and eliminate my labor requirement, then that's a reality I have to look at, which kind of really sucks, because I'd rather make the parts because it sounds really fun. But if you have to monetize something, oh god, it sucks so much. And I'm not even a really good expert in economic concepts. I just know enough from studying engineering and paying attention to what other people do, and then, you know, always trying to make money off of everything I do, that it's a pain. It really is. It's probably the only thing that, like, other economic models have going for them. But we need to figure out what we're doing down here. I really want to try pins again, even though it's a really dumb idea. Anyways, let me put shit together. So group, you are now another version of this. Let's drag you over here. So we always want to keep copies of every version we're doing. So this is where we started. This is now our new base version, and then we lock this. Now we want to add pins. So we can't do pins up here. We're going to use the cardboard itself to help hold that together. That is fairly easy to do and actually a really smart idea. Now I need to make a pin, and I need to make the pin big. Two things that are pretty much going to be annoying to deal with. Yeah, 5 is actually fine with that dimension. Let me make this 5. Maximize the bevel. And oh wait, it did not maximize. I like putting a bevel on these because it actually ends up making it slightly easier to deal with when it comes to the mold separating. Because again, if you have a square side, it doesn't want to do that, and that's just based off my own observations. If you actually go read a book on industrial design, I'm probably wrong on a lot of things. That's the reason why I call this a hobby, and this is not actually going to be probably my job. Because even if I end up selling these, it's going to be on the terms of like hobby novelist type concept. So I might only make enough to sell to a few people I know, or might not even make any for anybody. So we don't have enough material here to make that size pen. We can do another 4mm pen. Also notice the geometry doesn't line up with this photo piece. That's annoying. This is where I do need to learn CAD or Blender, because then I wouldn't have to worry about the geometry not lining up. I could just make the mesh move all the way down, because I can't really mesh edit this. Now what I could do is export this, import this into Blender, and then fix the mesh, but I have to relearn Blender. And that's a pain. I tried to actually go back and use Animator here recently, and it turns out they changed the software a lot. I'm impressed that they even fixed the software. Okay, so this is currently zeroed out, so that means I have 2.5mm of pen sticking out that side. That should work, because I don't think that pen is sticking out anywhere else. The downside is that doesn't give me a huge amount of material on the side. This is what will cause it to not want to form the pen on the other side. Because it will make the out pen just fine, because it's extra pulp material. It's going to fall into a hole. It'll do that. But then if you come over here and you try to put a hole, it's not going to want to do that. If this was plastic, it wouldn't be an issue. Well, actually, it's still an issue, but not as big of an issue. Yeah, let's not even do pins. We're just going to glue it. Because if a cardboard disc can work up here, I can glue a cardboard disc down here as well. I actually don't probably need to glue it. I just need to get it wedged in there. because when it goes to separate, I just need to make sure the disc is not in there bad enough that it won't separate. So I guess this is where we're going to just make this mold, which is, feels like really lazy, but sometimes your lazier parts actually work the best. Now, when I originally did the mold making process for these ones, I went through a really complicated process to it. I'm going to see if I can actually simplify this process more. So what I've also found is that oversizing your mold bodies really helps, purely because you do have to handle these parts, and it just makes it for convenient. So, I'm going to turn this into a hole, just so I can see inside of it. I need at least 10 millimeters of just stock material on one side, just to prevent my clamp from crushing it. We're going to go ahead and, so as you know, this is the same version we have over here. I'm just going to go ahead and rotate this one. Actually, I'm going to move it. I'm going to center this, because we always want to work with the center. I believe you're my other center. Because that means it makes alignment that's more easier. Let me check my dimensions on my parts. Aren't you like 17.56? So weird. This one's like 19.3, so I guess it's just weird rounding. This should be 17.5 is what that should be if I kept my dimensions right, but I think it did not cut it perfectly, which is okay having a little bit extra, because these parts are never going to fit properly together, just no matter what I do. And I'm going to go ahead and zero this. I'm going to bring another cube over here real quick. Make you 10 millimeters tall. Then lower you to the bottom. We're going to eyeball the 10 millimeter side because it doesn't actually matter if it's perfectly accurate. I just need it to be accurate enough that I don't have to worry about my part failing. I just realized I could do that. And I just deleted my center. So it's going to get that in there. So we want to then make this a certain height value. And I'm still trying to figure out this technique specifically, because I'm kind of guessing on the technique I'm showing you purely based off of observations I've seen in a few YouTube videos that were not related to the CAD design process itself. So we're going to be guessing quite a bit here, and we're going to see how it goes. And if it doesn't work, I will just show you the other technique I use. But now that we've managed that, I can then hide this part, turn that into, actually I clicked the hide button on that one rather than that two, and probably just messed up here. Yep. So I want to hide, turn that into a hole, show everything, turn this into a solid. And my theory is what I can try to do is I can cut the part out the middle, then somehow bisect this part. Now, this tool does not really have a bisect option as far as I've found, so this might turn into something interesting. It doesn't have a line and mirror options though. So we're going to merge this down. I'm going to turn this into a hole now. That's going to give me a perfect mold on this side. And the reason I'm doing this is when I was working with some of the other technique I was doing, the other technique I would do is I would make half the mold, merge the part down into that half mold, then make the other half from the inversion of that. And it kind of works, and it's kind of how you can make molds out of silicon in real life, and out of resins and other things. But it doesn't quite work. So this might not work either. Again, if this was yeah, if this was like Blender or something, I could just cut the thing in half. I can't do that in here. I don't think I get... I don't get a... There's a shape generator. That looks like that's used to generate complex shapes based off properties. This is more designed for educational use of what the software is meant for, which means I definitely need to upgrade to a better piece of software. You also can do like other things here, like blocks and bricks. Definitely made for kids. Because just cutting it away won't work. Yeah, we're just going to go back to my other technique. I'll show you how it's done here in a second. So the other technique, how I would do this, is we would basically change this down to 10. So I know I want to have 10 gap on the bottom, which means this needs to be 5. I'd make that solid. Then I would turn this into a hole, and the way we're going to more or less do this, if this is aligned correctly, do that little alignment trick over here. It says it's aligned, but it looks like it's slightly embedded into the part underneath it. So, how we do this? This is the only way I figured out in this tool. Because again, if we were using a proper software, this would actually be easier. Is I'm basically just going to make parts that fit inside of it and line up on it until I create a cutout. So 32 I think will work. Then if I center this, so you see that's going to fill in the main core gap there, and we'll deal with the bottom that's down here in a second. Well, we'll actually do it probably near the end of the video here. So we'll cut that up and clean off this model. But I can extend this until I see a point where it's going to probably try to clip. And I don't care if it's correct or accurate or anything like that, because that part doesn't really matter. What actually matters is if I cover the inside. I'm basically creating something for it to cut out material-wise. So for this, I'm going to change this to 30. This also to 30. And move this over here to act as the back cap. So that's going to cover these back two pieces. And what will end up happening is if I actually merge these down, is it will create the cutout for me. So I'll have my gap down here, I'll have my gap up here, and that would actually work for molding that. So it's creating my bottom half of that. So then for the front, I'm going to need to create probably a little bit more complex shape. Now I could probably get away with cylinders up here too, but you know, it's not too difficult to remember probably what my top radius is, which is 10. Apparently not. No, actually probably is 10, it's just probably really shallow. Base radius of like probably 32. Nope. That needs to be divided in half. So this is probably like 16. Let's go ahead and rotate this before I keep guessing on numbers and then it doesn't align. Rotate, center, move back with the arrow keys. So the base is correct, being 16. I then need to edit this, come back here, and then we can just increase the top until it doesn't clip, and then bring this one more forward. This is where things get slightly annoying because things are not lining up correctly. Okay, what is our actual size? So we need probably like 9.8. Nope. 9.5. That gets me incredibly close. And I don't actually need this mold to be perfect. It just needs to get as close to the representation I'm trying, because, again, this is being produced more for a hobbyist type project than it is being produced for anything else. My 9.8 actually probably is a lot more correct. Just, getting the alignment set up for this was a little bit tricky. I didn't have to go through this much trouble last time I did this, so I probably skipped a step somewhere. That looks like that is lined up really, really well. So if I merge this down, what I should end up with is a really, really good cutout. Now it's going to have some weird geometry issues like this right here, simply because the way we're merging stuff down isn't going to be perfect. But when the 3D printer goes to, spit it out, a lot of these imperfections that show up in the model aren't going to show up as badly. Some of them will still show up, because the printer will interpret the geometry and it will try to, well, not the printer, the slicing software will translate some of these imperfections into the steps it needs to do for printing, which might show up as weird ridges and stuff. But this is on the inside and I don't really care. So now that I've got this, I want to drag it over here, because I want it to not be kind of in the way. Because now I need to go ahead and bring out my next shape. And we're going to use an actual hole for this as well, because it just makes life easier. Now I'm going to estimate, I'm still going to need that 10 on the top, because otherwise if I don't have enough material, one of the first molds we made had like only a couple millimeters between the top surface and the outside of the mold, and the clamp literally just cracked right through it. And we definitely want to clamp these, because using your hands to just push molds together, you aren't going to get the mold completely to go shut. And the other thing is, if you're constantly pushing parts together, you're going to just stress your body out, because it may be like after you get to the first 10 or so, it's like, oh, I'm not tired, but after you get to the next like 50, 60, you then can burn out yourself really fast. And then somebody like me who's lost a lot of muscle mass, my right arm actually hurts from messing around with the clamps and trying to get them to shut as tight as possible. It's probably actually not only related to that, because I've been trying to exercise and do other things and lifting heavy objects and cleaning, but it definitely didn't help. So let's go ahead and zero this out, and then get this raised so it's over top. And then we do need this to be really, really close. I'm almost tempted to intentionally overlap it and then let the bottom cut out any of the overlap. But yeah, so I don't know how much material is above that. So let's go ahead and make a 10 millimeter peg. I'm going to go make this a 5 by 5 by 10. Go to top view. And then try to drag that over top. And somehow I made it 500 meters tall. I'm not entirely sure how I... What the fudge? That was abnormal. I'm gonna make that like that. I need to actually find what the hotkeys are for actually getting it to go up and down. Because I know you can use the arrow keys to make it move any other direction, but for some reason those arrow keys don't work. Like, even if I was in this view, it doesn't work to move up and down, which is annoying. But yeah, so I can need to increase the height of this to then cover that pin. I'm aiming for about 10 millimeters, which I don't think I actually need. This might be a little overkill. Because let's go over to this one, tinker this, and let's take a look at what my current mold thickness is. So if I go ahead and switch over to this view, you can see my drainage holes in there, which I'm not going to put in this version. I don't think there's 10 millimeters underneath that. Go to 10. You know, actually there might be. It's probably closer to 8. So we'll leave this one 10. That actually might be helpful. But yeah, let's go ahead and hide this so I can delete my pen. Then we'll show it again. And this is basically the step. We switch this to solid, we switch this to a hole. We select both of them and try not to move it because it happens a lot in the software. And we cut it out. And now I've got my 2 halves. And I've got a really weird gap on the side. Oh, you know, nope, I missed a step. The part I skipped, so let's go ahead and hide this. Turn this back into a hole. You need to put the part in here as well. So I need to grab this, and you have to unlock the copy too, which is a really weird quirk of this. I guess it makes sense. Unlock the copy, lock this again, move this over here, switch this to 90. One of the days when I was actually working on this, I ended up copying and moving this like 5 dozen times because I kept having to modify and fix various issues. And this part is where you actually have to spend some time aligning and dealing with the weird quirks of the software. Because it's going to want to do weird things. So this needs to be 10 millimeters off the ground in order to line properly. Now if I merge these two together, that creates my actual negative for the top. And if I show this, turn this into a hole, then go ahead and group these. This is the part I don't like about using this process and the reason why I was trying to avoid it. I have geometry glitches because something's not aligned properly. And these will show up in the 3D print, and they are annoying to get rid of. And I have not particularly figured out why they show up the way they do. So I get rid of this, hide that. I guess we can see them in there. It's probably because the mold underneath here isn't actually handling it properly. So if I turn this into a hole, click off, there we go. Top part turned to hole. We can kind of see some of the problems. There's probably a gap somewhere in here, for one. And the other thing is this may not be aligned properly. So 35, 17.56, is that the correct dimensions? This one's also 17.56. Also 35, somehow 18.78. It could be a rounding glitch, is the other issue that could be causing this. We do got some weird artifacting here. And if I went ahead and I just merged these two down, did it create? I can't tell if there's actually gaps in the material. So let's go ahead and break this off. I'm going to hide this. I'm then going to degroup this and pay a little bit more attention to what we're doing. Because we have good overlap. So that shouldn't have been an issue. What we could have problems with is that this itself is not as lined up as it should be. And this is one of the things I have had happen to me when I've designed these parts, is because we are merging a whole bunch of geometry together and we're not actually making sure the mesh is like perfectly aligned. It could be resulting in problems. It could be as a result of this part down here, which is an issue. So let's go ahead and unlock, ungroup, and then ungroup again. So this piece might not be aligned. How far are you off the ground? 10 tall, you're 30 off. We could drop it down slightly, and that would ensure it actually has overlap to the part below it. Doesn't make a huge amount of sense though. I'm going to regroup all these, and we're going to take another look at the model over there. Lock you. This could be part of the issue. Number of sides. Base radius, we'll try 17. That dramatically changed the size for whatever reason. 16.5. Let's go with that and see what that does. That might actually chop down better. Hide this. I want to increase this, the size of this a little bit more. So there's 33, 33. I have some concern I may no longer have it centered. But it looks okay. I really wish you could actually just show one part at a time. Take a look and check for any weird geometry issues. I'm not seeing any. So we might have made it work this time. And because this is what this was over here, we're going to have to copy this and move it again. So we have our backup copy of our bottom mold. I'm then going to want to show everything again, hide this again, turn that into a solid. I'm going to want to group it, turn it into a hole, and then look for weirdnesses. So yeah, we got the weirdnesses again. Because that's what those big cavities are right there. They're not as bad as they previously were. So it's undo, undo. There's got to be something wrong with the alignment of this part. That's the only thing I can think of. Because it's showing a problem here, and it's showing a problem right here. But it's zeroed out, and this axis, the height is the only thing that's different. Now if we go over to here, I could do 9.98 and just do a slight difference on height here, and this might fix it, because this is the trick we used to use in Minecraft to do stuff like Z-fighting fixes. If I don't move everything. Group, hole, still a geometry problem. So that's not going to fix that specific problem, because it's a geometry issue in the wrong direction. And this is why this technique kind of sucks. Because Usually it's the pens that break, which is also the reason why I didn't want to use pens. But then you occasionally get these weird discs show up. Now the slicer for the printer will just get upset at you. Now another trick we could use to fix this is we could just add extra geometry. If I turn this to the hole, I can literally just throw pieces down here. But you can kind of see it even when I turn this to the hole mode. They're literally, I can see the color. Where the rest of this has got this weird dark purple, this is just a regular kind of violet purple. Turn snap grid off. And you can see if I do it that way, we're going to get different kinds of conflicting. And does it register how much I moved it by? Oh. 17.5. What happens if I merge it down? Now, and I swear, I hate the fact that I'll go to drag, I'll have the mouse held down, it thinks I want to move. It's actually kind of annoying. Turn it to hole mode. We still got the things there. So sliding it over just kind of moves where those points are at. It doesn't fix them. Because yeah, now it's on the other side. So it's a precision issue. It's because we're using like perfect numbers, and we're trying to put another piece over top of it with perfect numbers. It's somehow inventing this like probably like 0.00001 gap between the parts. So what we could do is expand this by 0.1. Change this to negative 17.55. This means I'm going to end up with a slightly larger part on the exterior. That could cause problems. But it's about the only thing I can think of right now to fix it without me spending a really long amount of time messing with it. So we'll group down, turn to hole mode. Oh god, it's come up with more geometry. Okay, we're going to go with another IDO. So it's negative 17.5. So we know where the geometry problems are showing up. All we need to do is grab the cylinder, rotate the cylinder, make the cylinder some arbitrary size that's going to fit inside of it. Actually, 34 is probably the wrong size. 33, 0 U outs. Oh, that's right. Watt was operating off of not center points. Where's the little thing that's supposed to be down in the mode? There you are. There we go. 0. Oh, right, that's right, I don't have snap grid turned off, I can't do that. Negative 5. Oh, I changed the size. I don't think it's poking out that side there. Okay, so if we turn this back into a solid, we then merge it, turn to hole to look at the inside. We have a incredibly small geometry issue. That's right there. That is not a dot on my screen. Why on the world? That is... Yeah, like right there where my mouse cursor is at. There is a geometry issue. I don't even know if it's going to show up in the video. I'm just going to ignore it. Because, like, at this point, messing with it any longer is just going to cause more pain. So we'll do that, flip it over, if there is that geometry issue still in there, it's going to show up in a weird spot. And it's not going to matter too much. So there we go. We got the other side done. So now we've got 2 halves. The only thing I need to do now is create some kind of alignment concept, because you want alignment pins for the simple sake that no matter how you try, you're not going to get this line. Now, if I had a jig, like a wooden box or something that sticks in, I wouldn't need alignment pins. I could just drop this down there. I could drop this over here. Maybe drop a lid on top of it. One of the original videos I was watching for figuring this out, the guy recommended a 3-part mold rather than a 2-part mold, because with a 3-part mold, you basically put a base in there, you put the base in a box, then you have a basically squishing mechanism to go down. I'm like, that's kind of neat, until I realized I do need some level of precision. So we are going to make pins, and then at that point we should be done with the video. So I'm going to move this back over and center it. I'm going to turn this into a hole so I can see how these look. You can kind of get the concept of how much void space is going to be here. And if I knew software to go pick, I could probably tell you the volumetric on the inside of this and how much pulp it would take based off of the numbers. I don't have software for that, and I don't really want to go down the pursuit of making my own software, because I can do it. But then at that point, I'm getting into probably needing derivatives or something. I'd basically have to convert calculus to algebra for the computer to run. And I'd have to go like, how many slices of the object am I going to need to do stuff? Or, I probably could just, volume off that. If I really care about the volume, I could also just 3D print this part, go through it in a volumetric gauge of some kind, and measure how much water I displace. You learn that in basic science class. It's annoying, but it actually has its uses for this exact purpose. But yeah, I want pins. Come on, there we go. So we're just going to make like 5x5 pins. And I need to remember to undersize my pin ever so slightly, because on my current model, and I have a printer that can actually print really precise now. I bought like a vide, I think is how you pronounce the name. I bought a vide printer for myself for my birthday here recently, and I was like, I really like to have another small cheap printer, because the first printer I bought was a Mini Delta from Monoprice. It's actually not made by Monoprice, but they put their branding all over it. Really good printer if you don't need to do anything weird with it. Unfortunately, I ended up wanting to do weird stuff with it, and then I ended up trying to upgrade it, and then I ended up breaking it badly, and then had to go do a whole bunch of stuff to fix it. But the vide one, I ended up picking up again, because I'm like, I want another good printer that I'm not going to mess with. And like, I had a little bit of trouble out of the box getting it to run, because I took the adhesive tape off the bed. It turns out that was meant to be painter's tape. It just wasn't looking like painter's tape, and it's an unheated bed, so it needs painter's tape. Put that back on. I've been getting it to print amazing, and I did some really simple, just take the nozzle off, put it back on, and redo the Bowden tube with, I forget the name of the blue tube that everybody loves, but I think it's Capricorn. I put some Capricorn on there because I ended up melting my original tube, and now that I've got it put on properly, the thing is precise as hell. Like, I haven't had to do any flow rate adjustments on it, because I don't even think I can. I haven't messed with the E-steps, haven't messed with anything, and it just prints precisely. The corners are barely off. Like, you have to pay attention to them, and with a little bit of sandpaper, they would be precise. So like, this little corner might be bowed out just ever so slightly by like 1/10 of a millimeter. It's actually really good precision. But the pins that it prints almost perfectly fit with no tolerances added to the model. So I'm going to add a little bit of tolerance to the model so that they fit actually correctly, and I actually would get some good bolts. So we're going to do, I don't know, 5 millimeter. And then it's like, what, 10? This will need to be 12.25, I think. Nope, my math sucks. Because I'm not actually working out the right metric, am I? No, that is correct. This would just be... No, that is center points. Okay. This is what I want. That would be 10 to the bottom. So if we minus 2.5 off that, 7.5? Yeah. I don't need the alignment points to be good, like that precise. I'm going to hide this now, just so I can do this without it being a pain. Oh, that's right. I don't have snap grid turned on. Do snap grid some. I don't go insane. Okay, let's also fix you so you're actually aligned on the corner properly. I don't need it actually to be aligned, I just need both of these sides to be correct-ish. So we'll do 18, so that way it's off the corner. I'm not going to bother doing any like precise math. We're just going to go and make sure that the sides match each other. Why? Oh, because you're not centered. Negative 20, 20. Yeah, that'll work. So that is now precise. That means there'll be an even amount of material on both sides. I want to say 2.5. That'd be 2.5 millimeters of material on both of these, which is pretty good. So that gets me those. And then somebody suggested to me, which that somebody being one of my housemates named Alex, actually was like, hey, you should 100% do alignment pins, and you should make them so that they're not symmetrical on both sides. So there's only one way to put the mold together correctly. Now this one, it looks like I goofed a little bit, and I did not calculate for enough material on this side. I have more material on that side than I do on this side. I also could put the alignment pins like right over here, but I really like the 3-pin design. Let's make these pins smaller. Because that'll give me at least a comfortable amount of material on both sides. And what I'm going to go ahead and do is I'm going to duplicate these, get them aligned back up with each other, and then bring them up. The reason for doing that, these are going to become my holes in a second for the top side. The only problem is I need to make them slightly larger. 2, 2. I don't know if that's going to work properly. So if I run that down, are you centered still? Yes, okay. So it kept the centering. I just need to make these also the same size. So that'll give me like a very small amount of tolerance. I don't think my printer actually can do that level of tolerance, but it should mean that when the slicer runs it, it should be just enough of a difference that they'll probably fit together a little bit better. But anyways, I need to then pick a perspective that's going to work so I can actually select everything. Group these together. Then I'm going to unhide the top. Hide the bottom. Somehow magically managed to select that, which I'm impressed. That's right, I can't drop. You use the arrow keys to make this go down. When I get to the point where that's basically barely sticking out, because I actually want there to be a lot more depth for the pin to go down in case anything gets stuck in it, like cardboard. Gonna drop these down a lot and then re-show that. You again. And then what I should be able to turn that solid. Merge these down. That gives me my holes. If I do show, and then turn this transparent, I should be able to check my precision. Somehow that one didn't work properly. But that one's got gap, that one's got gap. So let's go ahead and hide this. Ungroup. Figure out how I failed on math. Because I changed the wrong dimension. so you should be 5. Let's go ahead and change these to 11 off the top, because that'll give it a little bit more space above it. And that should work. So I'm going to go ahead and merge that together. Show the other part real quick. Turn this into a hole and check the work again. Okay, so we've got our 2 halves. Now the things I need to make sure I do is I need somewhere for the water to go. Because if we get these to precisionally go together, the water's got nowhere to go. I also need to clean up the bottom piece here. Now I could let the water come through these areas, which might help with material getting down to this part. I think it's a better idea, because I was putting injection pins on this side, more or less, is what I was also using the drainage holes for, but I don't know if I actually need that. No, yeah, I do need that. So we're still going to need injection holes on this side, but I guess we can put holes on both sides. Because I don't really need to clean up anything, but let's go ahead and make this solid. I need to flip it around. Not 90 degrees, 180. Bring it over here. And drop it to... That's so much significantly bigger. Yeah, I need to clean up the junk off the bottom of this. Which is fairly easy to do. I just go like 50, 50. 20 should be fine. I just make it negative. And then just zero it out. And then we just merge it together, and that should delete that bottom junk, so it won't 3D print now. That's the reason I said I don't care about that near the end of the video. It's just like delete it. It's fine. But I want to put holes in here so that way I can get some drainage going. And I think the previous holes I used were 3 millimeters. I have a drill bit that's about that same size, so I can use the drill bit to push the part out. Or, you know, clean up the holes. That should be 4 millimeters, which is a bit of a problem. So we want to center this. And then I'm just going to use the keyboard to walk it over. Okay, so we're going to use some kind of like half measure here. It does not give me a lot of material on each side. I don't really care when it comes to a whole how much material on both sides, but it's still something to consider. That the 3D printer might care how much material is there. But yeah, we'll go ahead and put a couple drainage holes. And I hate how this doesn't paste this with the same measurements you're working with. So when you're trying to work with it and you're like, I want to put something here, and you're like, I'm going to copy this and I can mirror it to the other side, then it will forget what you're doing. So 10 and then negative 10. So that gives me 3 drainage holes there. And then, ironically, this might end up creating the injection pins, just purely because I'm adding weird drainage hole places. Okay, looks like I might not have enough space to do that there. Oh, I spoke too soon. That actually will work. I'm just going to want to have to move it all the way down so it's like perfectly down there, so I'm not breaking the geometry on each side of it. That'll let me drain off that side. I just do negative 14.5. I guess the other side, and if I merge this down, you know the other thing I probably should do rather than alignment pins, I actually should put like an actual meshing geometry around this. That might help a lot too. Make it align a lot better. But yeah, group it. I know, I have drainage holes. It's really simple to add these, and they're kind of neat. They're useful. I don't know how practical they really are. Because I may, like, once I go over to the mesh stuff, which I think it's Maker of Music's got a video where you can actually put meshes in your parts, and I need to go watch it. I've only seen like the first few minutes of it, and then got bored. So one problem with me watching videos is that I might get bored. The video might continue to play in the background, but then I'm like not paying attention whatsoever. It's nothing personal against some of the videos, it's just like, that's how my brain works. That's also why I also don't watch people live stream, even though my girlfriend really wants me to watch her live stream. It's like, it has nothing to do with you personally, it's just that's my brain does not want to sit there and watch that kind of content. Regardless of how entertaining it actually might be. Although there's some days I will log into her stream and try to generate engagement, I guess is the way you can call it. Because I won't be participating personally, but then I might be trying to encourage other people to participate. The spacing on this is killing me here. It's not even. I think that looks closer. So I'm going to do my same 3 alignment holes, and then this is going to why are these so badly off-centered? Because I don't think 60... What happened? It's done something weird. Yep, it's moved it by like a decimal point. I hate it when it does that. This is the problem when you're copying multiple parts, is that it likes to paste them in a way that doesn't actually make sense. I have a snap grid of 1 turned on, yet it's doing decimal points. So you are 65. Okay. I don't think it's how I had this laid out last time, but I think I'm going to go with it anyways. I do need to do a final step afterwards, though. Okay, how far are you away from the edge? You are -9. 9. There we go. So do that. And I should be able to bring this over to 9 as well. Or in this case, it's going to do half because it's the way it pasted. There's actually a CAD software that I don't remember what it's called, but you actually generate everything with math that I probably should switch over to, because the way I actually build models, doing math probably would suit me better, because I am doing a lot of, in my head, calculating, like, I want this to be this far away from that part, and I'm basing them off relative positions, which I think it can do, because my brain thinks in terms of that relative positioning of the parts. And I went to go drag again. There we go. Merge down. That gives me my holes. So the last thing I need to do, because I'm going to be clamping these together. Now, the clamps I have are 80% of the width, roughly, of this 50mm part, which means they cover my holes. So I think the way I can get away with this would be to add maybe some grooves. Because I don't want to do something really complicated and start adding like airways coming through the part. At least not yet. I think just grabbing a really quick cylinder, bring it down here real quick. Move it 90 degrees. And then keeping it like some really small diameter number should work. Now the trick with this would be is if it will actually decide it wants to print. So we know it's 50, we'll do 55 hole. So now I just got to align it. Luckily it's giving me this nice little pretty roller right there I can use to align it with. Actually works out better than I thought it was going to work. How far are you aligned off whatever I'm trying to align you off of? I think it actually says it's 0 based on that number over here. So I actually might have a halfway in there. It just doesn't look like it. I mean, it actually doesn't look... Oh, no, I think that's the number I actually want. So make you a 0. There we go. You're actually in the middle now. So that's going to create a groove for the water to escape from. I should be able to drag this over and get that to line up. For some reason that's being weird, again with the pasting. And then we're going to want to do that to the other model as well. But seriously, you just... and you lined up well and you just pasted weird. Kind of love simple software like this. I don't think I've ever had this problem in Blender before. Actually, I say that and I've had so many other problems with Blender, so I guess it doesn't really count if one of your problems is not as bad as the other, if both of them have problems. So go ahead and select this one only, merge down. Select this one only, merge down. And that gives you drainage holes. Now this does mean I'm probably going to need supports, which I'm not going to be thrilled about, but it should mean I should have water coming out of this a lot better. And I might be able to stick a really fine cheesecloth or mesh over these holes so that only water is getting out and not the actual thing. But I'm going to go ahead and end the video here because this is way longer than I was anticipating. With a little bit of debug and trial and error, and you can kind of maybe see some of the mindset I go through when I build these parts, and I will potentially make more of these videos as I go, as I want to get more into the design aspect of this. Maybe not as much as the 3D printing side, because I don't really think I'm the kind of person to do how a 3D printer works and how to make your 3D printer work and how to, you know, go through all that stuff. There's better channels for that. But I can go through the design side and engineer parts and show the parts being engineered and try to do cool little creations in between any future kind of coding stuff and everything else. As I will be planning coding sessions kind of concept, because I want to start showing off some of the stuff I've been doing at work, for example. There also is talk in my work about doing tech blocks, which I may be asked to do some. And then there's also the idea of like just kind of want to show off like React and Node.js, Express, GraphQL, all these really cool tech, and then maybe show how we can use those in modding to create really cool tools or integrations with our mods to make them do more neat things. But I'll see you all later, and thank you for watching.